Hello everyone. So in our previous lecture, we had a discussion over the atom. What are the theories about the atom? What is the atomic structure? And also we had discussed that atom has several points like the protons, neutrons and electrons. Okay. So in this chapter, we are going to learn about different chemical bondings, or you can also say chemical combinations. Got it? So let's start. First is, what do you mean by chemical bonding? The first question is, what do you mean by chemical bonding? To understand the chemical bonding, we should first understand what do you mean by bonding. What do you mean by bonding? Okay. In your childhood, or also when you were in your school and when you were in college, okay, you know that some people have bonding. Some people have bonding which we call friends. If there is a group of friends and then you say, what is a thing which attracts them to be together? And this thing named as bonding. So what is the meaning of bonding? Bonding basically means mutual need and mutual help. So basically in simple terms, we can say bonding is a mutual need and mutual help. Like there are two people, this and that, who are the good friends. Okay. He also required something to be done. Like he want to share his feeling. Sometimes he require help. Sometimes he require help. And because they both need something and because they both could help each other. So that's why they are a friend and that's why they're having a bonding. Got it? Similarly, in chemicals, we also require some mutual need and mutual help. And what are these? We will learn in this lecture. Got it? But remember one thing, in the field of chemistry, we have several fundamental laws and principles that govern chemical bondings. Okay? And how does the molecules and compounds form? Got it? So, in our previous lecture, we had a discussion over compound formation. Compound formation. Like we say, compound is made up of element. An element is made up of single atom. But because compound is a group of elements, so it may have multiple atoms. Got it? So what about molecules? Basically, molecules is a group of atoms. Molecules is a group of atoms. Like single atom, double atom, triple atom, and then they both get combined together, then they are the molecules. Okay? Single atom, second atom, third atom. Then they all combine together and form the molecule. Got it? So basically there are several laws which governs that how these molecules will be formed, how this compound would be formed. Got it? And basically the chemical bonding, the entire term of chemical bonding could be divided into two main forms: ionic bonding and covalent bonding. Like here, ionic bonding, thereafter the covalent bonding. Got it? So let's start. Before starting this bonding, we need to understand the octet rule. Octet rule. Got it? Basically, the octet rule was given by two persons. First one was Walther Cosell. And second one was Gilbert Lewis. Okay, so these are the two people who gave the octet rule. Okay, Cosell was belonged to Germany, whereas Gilbert Newton Lewis belonged to America. Got it? So these were the two people who gave the octet rule. And what was the octet rule then? Remember one thing, that Niels Bohr gave an atomic model and says that nucleus light at the center, and then there are some orbitals or shells where electrons revolve around it. Remember, I had told you in a previous lecture. Okay, so in that time, as you can see that there are some orbits. There are some orbits in which the electrons are revolving. Got it? So basically, octet rule says that in the outermost orbit, suppose this is a nucleus, the first orbit, the second orbit, the third orbit, and the fourth orbit. Okay, so in the outermost orbit, like this one, there should be almost 8 electrons. There should be almost 8 electrons. Okay, if there are no 8 electrons or they are less or more, you can say either they are less electron or there are more electrons. If any of such condition prevail, then the atom will be unstable. The atom will be unstable if it has less electron or it has more electrons. So we can say in order to be stable, it required 8 electrons in the outermost shell. In the outermost shell. Got it? So that was the rule given by the two persons, Walther Kossel, and second one was Gilbert Newton Lewis. Okay, so this was the basic concept of that octet rule. Got it? Thereafter, how does an atom, like this is an atom, if it has more electrons or it has less electron, then how does it can get the stability? So in case of more electrons, it required to lose them. In case of less electrons, it required to gain them. Okay, just take an example, like it's electron A which having 10 electrons in the outermost shell. This is electron B which having 6 electrons in the outermost shell. Okay, so what did you notice in this? You notice that one is in surplus. One atom is in surplus, whereas another atom is in scarcity. Another atom is in scarcity. Got it? So what could be happen in this scenario? So suppose if A, which having the 10 electrons, lose 2 electrons because 10 minus 2 is equal to 8. So somehow if A loses its 2 electrons, then it will achieve 8 electrons in the outermost shell, which is required to be stable. Whereas in the second condition, suppose B, which having 6 electrons, if it gain 2 electrons, because 6 plus 2 equal to 8. Okay, so if somehow B is able to get 2 more electrons, then it will have 8 electrons and it is a condition for stability. Got it? So could we say, so can we say like A having 2 should give 2 electrons to B. Okay, when it happens, then A will have 8 and B will have 8. Now the condition is stable. Got it? So this was the basic example, you can say, or basic concept. Got it? Now come to the next point, which is the noble gases. Noble gases. Basically, noble gases are of the group 18 elements. We will have a discussion over this group 18 and periods when we will learning about the periodic table. Till then, just remember, noble gases belong to group 18 elements. Got it? Group 18 elements, and they are stable. So So does having 8 electrons in the outermost shell. Okay. So here we have finished about the octet rule. Octet rule simply states that if an atom requires to be stable, then it needs 8 electrons in the outermost shell. Okay. If it's having more and if it's having less, then the condition will be unstable. Got it? Now come to the next point. As I've told you, atoms can gain or lose electrons to form ions or share electrons with other atoms in covalent bonds to complete their outer electronic shell and become more stable. As I have told you in the starting, that chemical bonding having two divisions, ionic and covalent, which we will learn in this lecture in a short time period. Okay. So just remember that electron could share and could gain, or you can say could lose the electrons to get the stable conditions. Okay. Now let's move forward. In this example, so this is the example where you can check it. Like there are 2 atoms of chlorine. Now look carefully. It is the outermost shell. How many electrons they having? 1, 2, 3, 4, 5, 6 and 7. So they having 7 electrons in the outermost shell. Got it? And similarly in the second one, 1, 2, 3, 4, 5, 6, 7. Second one also having the 7 electrons. In outermost shell. So something should be done to attain the stable condition. So in this scenario, what they did? They started sharing the pair. Like 8 having the 7, 8 having the 7. So now they are sharing it with each other. Okay? With each other. Got it? Now let's count the electrons again. 1, 2, 3, 4, 5, 6, 7, 8. So the atom 1 having 8 electrons now. What about atom 2? 1, 2, 3, 4, 5, 6, 7, 8. It also having the 8 electrons in the outermost shell. So now we can say they are stable. Got it? Now let's move forward. So here we having laws of conservation of charge. So basically, law of conservation of charge states that total electrical charge is conserved in the chemical reaction. Like whether it was A, then it was B, and they both started pairing the pair. Okay. Before this, they were the electrons, and now they are the compounds, because that time they were the individual electrons. That time they were the atoms, and that time they were the atoms, and now they are the molecules. Okay. So before the merger, A and B were separate, you can say the separate atoms. But after the merger, both A and B got combined and it is the molecule. Got it? Now let's take an example. In an ionic bonding, when atom transfer electrons to form ions, the total positive charge of the cations equals to the total negative charge of the anions. You can say basically in the form of ionic bonds, we having the 2 divisions, cations and anions. Got it? Cations are basically positive charge particles, whereas anions are basically negative charge particles. Okay. So whenever A getting combined with B, Okay, so it will never be happen that in some scenario cations are increasing, in some scenario anions are increasing. Okay, so we could say to balance the equation, cations are always equal to the anions. So the positive particles are always in accordance with the negative particles after the merger or after the combination. Okay, as per state by the law of conservation of charge. Got it? Now let's move forward. Coulomb's law. Remember, in our physics lecture, we had a discussion over Coulomb's law. It states that if there are two particles, so their force of attraction will be direct proportional to charge. Direct proportional to the charge. The more charge A and B will have, the more will be the force of attraction between them. And it is inversely proportional towards the distance. So we can say the more the distance will be in the A and B, the more less will be the force of attraction between them. Okay, so it was the Coulomb's law. Got it? Remember, in the physics chapters we had a discussion over them, right? So here in chemistry we also learned Coulomb's law for description of the electrostatic attraction or repulsion between charged particles. So basically you can say here it is deals with the opposite charged particles. Remember, in the chapter of magnetism, I had told you that opposite charges, whether it's for positive, then negative. So I had told you the opposite charges always attract towards each other. Okay, whereas the same charges like the positive, and you can say the positive, and then you can say negative and negative. Whenever there will be such kind of condition, they will always repel each other. Okay, in this scenario there will be attraction because they both are in different phase, but in both these scenarios there will be a repulsion. Okay, they will repel each other. Okay, so Coulomb's law basically states this condition in the field of chemistry. Okay, now let's move forward. It states that the force of attraction between two charged particles is directly proportional to the product of their charges. Basically, you can say, like, if there is a positive charged particles and this is a negative charged particles, they both will attract towards each other, but the more charge they will have, the more will be the force of attraction. Okay, and more apart they will place, there will be a low attraction. Okay, or you can say if they both are of the same, like the positive and the negative, then there will be a no attraction, but there will be a repulsion. Got it? Now let's move forward. So now we having a valence shell electron pair repulsion. Basically, theory explains the shape of molecules based on the arrangement of the electron pairs. Okay, so this theory is very much based on the same charge phenomenon. Very much same with the same charge phenomenon. Remember, I had told you, like, to get the stable condition, the atom has to share the electrons between them. Got it? And electrons are of the negative charge. Electrons basically are negative charge particles. Okay, so whenever they will be combined together, and they will form the molecule, then there are high chances like the electron will have to combine with the electron. And remember, they both are negative. And I had told you so many times that negative negative and a positive positive, or you can say the same charges will always repel each other. Okay. So to tackle with this condition, the molecule has to arrange itself in a manner so that the electron could be combined together without repulsion. Okay. And due to this, various molecules has to change their shape to arrange the electrons in a proper manner. And this always described by the Valence-Shahn electron pair repulsion theory. Got it? Now let's move forward. So here we have a laws of conservation of mass, which was given by Lavoisier. And Lavoisier is also known as the father of modern chemistry. Got it? So law of conservation of mass basically states by the Lavoisier, and Lavoisier is also known as the father of modern chemistry. So basically Lavoisier says that if there are two things like A and B and they both get combined to AB, okay, so their mass before and after will be the same. Basically we could say, suppose if A is 10 and B is 20, and then they both combine together to form AB. Now A is 10, B is 20, then total mass will be 30. There will be no change in the mass. Okay, and it was the law of conservation of mass. Basically here you can see that the mass of reactants, which are A and B in this scenario, and mass of product, which is the AB in this scenario, will be the same before and after the reaction. Got it? So it was a law of conservation of mass which was given by the Lavoisier. Okay, and accordance with this law, there is also one law which we called law of constant proportion. Law of constant proportion. This law was given by Joseph Proust. This law was given by Joseph Proust. Okay, basically as we know that before and after the reaction, the mass of the reactant is equal to the mass of products. We know by the law of conservation of mass. But the question is, what is the force and what is the theory behind it? Okay, so that was explained by the law of constant proportion. So in this scenario, like A having a 10, B having a 20, and after that both A and B get combined together. Okay, in this scenario, before the reaction, A ratio B will be 1:2. Got it? And after the combination, still A could only contribute 10, because I have told you that atoms cannot be created, cannot be destroyed. Okay, so A only having a 10, so it will contribute 10, whereas B only having a 20, so it will contribute 20. Got it? So before and after the reaction, the ratio will be 10:2, and that's the reason why the conservation remains same before and after the reaction. Got it? So remember, the law of conservation of mass states that mass of reactants will be equal to the mass of products, was given by Lavoisier, who was considered as the father of modern chemistry. Second is law of constant proportion or definite proportion, given by Joseph Proust. Okay, it states that chemical compound always contains the same elements in same fixed proportion by mass, regardless of source of compound. Like A having a 10, then it will be contributed only 10, because atoms neither be created nor be destroyed. Got it? Now come to the next point. As you can see, in other words, the ratio of the masses of constant elements in a compound is constant, as I have told you, and this law is given by Joseph Proust, which already I have told you. Okay, now let's move forward. So it is a ionic bonding. So basically ionic bonding is like a friendship where atoms share electrons to become best buddies. Okay, like in this scenario, here is A and here is B. A having 9 B having 7, A having 9, B having 7 electron pairs. Electron pairs. Okay. So in this scenario, A is in a surplus of 1 electron, whereas B is in deficit of 1 electron. Got it? So what could be done is this scenario. So does A will have 8 and B will have 8. So to manage this scenario, A can give his 1 electron to B. So that's why 9 minus 1 will be 8 and 7 plus 1 will be 8. So that's how they both can solve their issue. Okay. So basically in ionic bonding, there is a complete transfer from one to another. Okay. So basically ionic bonding, there is a complete transfer from one to another. Got it? Like imagine you have a two atoms A and B, as I have told you. Okay. And simple scenario, but now we will change the value so that we could understand it better. A having a 10, B having the 8. Sorry, B having the 6. Now what is happening again in this scenario? Again in this scenario, A is a surplus of 2, whereas B having deficient of 2. Where A having a surplus of 2, B having a deficit of 2. Then what should be done so that they could be managed to get a stable condition? Simple. Again, if A transfers 2 electrons to B, then A will have 10 minus 2, 8 electrons, stable conditions. Similarly, for B will have 6 plus 2, 8, stable condition. So that's how again the problem could be solved. Got it? Now let's move forward. It's the same thing which I have told you. Okay. Now the covalent bonding. Basically in covalent bonding, remember there is no complete transfer, but mutual sharing. So basically in covalent bonding, there is no complete transfer, but mutual sharing, and that's why it is a wonderful teamwork. Okay. And how it could be possible? Let's understand it. Remember the chlorine example where one atom of chlorine having 7 electrons. 1, 2, 3, 4, 5, 6 and 7. Similarly, the another atom having the 7 electrons. 1, 2, 3, 4, 5, 6 and 7. Okay. In this scenario, they both are in deficit of 1 electron. Okay. So if it gives its electron to Cl, then again the condition will be unstable because here it will have to sacrifice its electron. Similarly, if this one transfer its electron to this one, then again the condition will be unstable because it will have 6, it will have 8, but the condition is not 8 is equal to 8. Okay. And also we know that we need to acquire the same condition. So what should happen? They both should share this pair. They both should share this pair so that no one has to sacrifice its stability. So in this scenario, if they started sharing these electrons, so should we count them like 1, 2, 3, 4, 5, 6, 7 and 8 electrons. Okay. Similarly for this 1, 2, 3, 4, 5, 6, 7 and 8 electrons. Got it? So now they both having 8 and 8 electrons. Got it? So this was a common logic behind the covalent bonding. Like in ionic bonding, there will be a complete transfer from one to another, but in covalent bonding there will be no complete transfer, and they both having a mutual sharing. So that's why we also called it as a wonderful teamwork. Okay, so students, in this lecture we had finished about the chemical bondings. In our next lecture we will start with the stoichiometry. So students, in this chapter we have finished about the chemical bonding. In our next lecture we will start with states of matter and phase changes. Till then, thank you.